Welcome back to the morning show. It's 6:46 and our favorite time of the week. It's Wise Guy Wednesday.
Wise Guy Mats Selen joins us at a U of I laboratory this morning with an experiment that's going to blow us away, Matt.
Well, I hope it doesn't blow us up, though. We'll see what happens.
That would be a good idea.
So last week we used the pressure from the atmosphere to crush a 55-gallon drum. You may remember that was pretty cool. And I want to talk a little more about that pressure today. There's a way that we can actually demonstrate how big the pressure is. It turns out it's 15 pounds per square inch. And what I have here is just a little aluminum sphere that's been cut in half. On one side of the sphere there's a rubber seal, and the other side is just kind of flattened out. And so what I can do is I can put these two halves together, and I can suck the air out that's inside here, and we can see what's going to happen. And basically, there's grease in between these two things, so there's nothing that's going to try to make these things stick together other than a pressure difference. And so right now, I can pull these things apart real easily because we have 15 pounds per square inch on the outside as well as on the inside. But what I can do is I can use my little handy-dandy vacuum pump. I can just turn it on for a second here. So right now, I'm just pumping the air out from the inside. I'm going to close this. Doesn't take very much. So right now, there's no air left on the inside of this thing, so there's zero pressure on the inside, 15 pounds per square inch on the outside. A square inch is about the size of a quarter, and you can imagine you can get a lot of quarters on the side of this thing. So there's quite a bit of pressure. It's going to take a few hundred pounds to pull this thing apart. That means I can actually use it to lift up something heavy. So what I have here is a couple of big cinder blocks, which weigh about 100 pounds altogether. And I have this big crane that we use in our lab when we build our physics experiments, and I'm just going to use this thing in between to hoist this up. So here we go. Okay, so right now, this thing is supporting about 100 pounds of weight, and it could probably support twice as many cinder blocks without falling apart. And it's just due to the pressure of the atmosphere, so that's pretty impressive. What do you think?
So you haven't locked that at all?
No, not at all. In fact, let me lower it so it doesn't make a big mess, but I'm just going to now open this little valve here, let the air back in, and you're going to see this whole thing just plop to the ground. You'll hear a hissing. There we go.
Huh.
And all I did was let the air back in, and the thing collapses. And so the way you can think about our atmosphere, actually, and why there's pressure at the bottom, is just think of the atmosphere as a giant swimming pool. You know that if you go swimming at the pool, if you dive to the bottom, you feel pressure on your ears. Well, we're at the bottom of this giant pool, which is sort of like our atmosphere, and so there's a lot of pressure from all the air that's above us, and it adds up to quite a bit. And we don't feel it because we're basically used to it, and because the pressure inside our bodies is equal to the pressure on the outside. And actually, next week, or in the next segment, we're going to talk about what happens if you remove the pressure on the outside of our bodies, what would happen. So that's kind of an interesting thing, too.
Does sound interesting.
Okay, Mats, we'll be back with more, or 4 more physics fun coming up a little bit later this hour. Well, coming up, are you looking